So we are most pleased that Wolf managed to make it here. And we are looking forward to listening to Gunnar Wolf, which is his actual name, describe the current challenges for the OpenPGP key server network. Thank you, Gunnar.
Thank you very much. Oh, thank you very much. So, I'll be starting with this. What I'm going to show, what I'm going to tell you about is not exactly, or it's not directly tied to what I do in Debian. It's not related. I mean, it is related to my work in Debian as a keyring maintainer, but I started 1.5 years ago doing a PhD, and well, this is the subject I chose to work on. It is related to my task in Debian, but please do not take this as something that will be directly applied or directly useful. I hope it will be, but I can only hope so far. It is relevant to how the free software world handles its relation with the OpenPGP ecosystem. I think it should be relevant in the long run, but at least for now, I hope it's interesting and entertaining. I will have an introduction that for maybe most of you, it will be, well, just what you already know, basically old news, but I have to do this, right? Why am I starting with this? Well, because internet was not meant to be what it is now. The internet started being a happy, naive network when everybody trusted the packets they received to be from where they were supposed to mean. And then things started getting more complicated and worse, and bad things started happening on the network. So many people say, okay, but right now we are at 80% HTTPS, so cryptography solves everything. And yeah, the thing is that most people don't understand what cryptography brings us and what it enables us to bring, but requires some extra steps. So the level of cryptography on internet right now does prevent eavesdropping. In Mexico, we use the phrase that when somebody's eavesdropping on your communication, there are birds on the wire. So, I mean, this is my reason for this illustration. HTTPS or similar schemes will take care of most birds on the wire, but it doesn't get us all the way through. It does get strong cryptography, strong enough to be, say, with current technology, practically unbreakable. It uses strong algorithms. Maybe I should review this list because it lists some algorithms that are deprecated, so whatever. But cryptography does work over very different protocols. I mean, I keep referring to HTTPS because that's what most people see and most people identify. But of course, we need also cryptography to apply over local storage and over email and over many things that are not what most of the world thinks. I know you are not most of the world, but still. Of course, it doesn't hide the fact that communication occurring between participants, and by itself, cryptography only gets us some way towards verification of the correct identity of the participants. So this is where PGP comes in play. PGP is a project that's over 30 years old, and it shows, and it really, really shows. I'll go over, well, some of the good highlights of PGP and some of its current challenges. Again, knowing that most of you already know part of this, so I'm just skimming this part of the material. We need to do identity verification. We are using this to build authentication systems. So what does it mean to verify an identity? I cannot expect to know everybody, every party I interact with on the internet. The internet is just too large for that. So I have to build a trust model. who can I trust and how can I relay this trust? I start by saying that I can trust somebody, and I get to choose whom I trust. And I can trust some set of people or some set of actors to give me a truthful information. So that's where a transitive trust distribution mechanism starts. So most people are familiarized with the centralized trust schemes. That's where I give via a document that's centrally emitted. I verify, or someone verifies this document, and well, it may act as an authority, as somebody, as a gatekeeper. So this is the most usual trust model on the internet. For many use cases, I really prefer, and many projects really prefer, having a fully distributed trust system. Yeah, where, well, each of us introduces to each other, and we build a collective trust. So we can talk about centralized mechanism as the certificate authorities, PKICA models, where we define the ultimate roots of trust. That is, our computers are shipped by our operating system, Debian, ships with a list of authorities we trust, and that comes from the CA browser forum. Although, well, it does work, it provides for most cryptographic exchanges in the world, but it's not centered on the users, and it's not affected by my personal decisions. The distributed mechanisms will be centered on each of the users. That's what we do as a social group, and every one of the users can certify others by saying, I trust this person's identity to match a given cryptographic key. Each person, each actor will have a different signing policy. Each person will relay trust to others based on personal criteria. And well, trusting someone's identity doesn't mean trusting the person. That's something very hard to convey to people who are not already into this. The personal network of interactions with a web of trust. Of course, one of the main reactions to this is, well, how can I trust the different people's criteria to sign? Well, that's not what I'm aiming to, but it's something that people that use these models should be aware of. Of course, there are other models to convey trust on somebody's identity, but these are the two ones I'm contrasting, and I am mostly focusing on the Web of Trust model. Yeah, I mean, again, I know I'm giving a lot of introduction. Maybe the introduction is too much for most of the audience here, but some people may be following that don't have this whole background we share. So cryptographic interactions where I don't have to, where I trust central authorities and certification authorities follows this model, the centralized model. And in PGP, in OpenPGP, we use this, like the Web of Trust, that's centered on the person that's, on each person that's assessing the trust path to any other person. Of course, one of the main weaknesses of the Web of Trust is that it requires each person to know many people. Well, of course, some of you have been to traditional key signing parties where we lined up in two lines and started checking each other's identity, backed by government-issued IDs. And, well, yeah, this is very good because it leads to closing in on the I mean, getting a much higher connectedness on the graph. The problem is that traditional key signing gets up to 300 people interacting with each other, checking each other's documents, and that has been shown not to work. That has been shown to be, well, a farce. We all took part of it with the best of our intentions. As you all know, we have switched away from this interaction model to something that's much less condensed, where people meet informally more in this setting I showed before, and check the identities of people they really have interacted with and that they really can personally identify, which is much better, right? Okay, still, we have cross-signed keys of each other. We all have made a strongly connected graph, but there's still one issue that has to be taken care of. How do we distribute the keys? So, if we link our personal identity to a very big number, it's like tying our identity to a telephone number. We need a telephone directory. We need some way of, for somebody who doesn't know me to go find my key somewhere. And it's not a trivial thing to request. Under the centralized models, there are certificate authorities who will certify in a way that's embedded in each of the certificates when I go to the site. But if I want to send you a mail, there isn't, I mean, the mail protocol doesn't have a first back and forth step where I am sharing you the key. In the regular use case, there are others. We must obtain the key before sending a message, and that's where the PKS, that's basically the key server network, comes into play. It's a network that holds, well, all the mappings between human identifiable personal IDs and the key fingerprints, the key, well, what identifies a key and the key itself. But again, I want to avoid centralization. How do we avoid centralization while having a key server? I don't want one big key server to be in charge of everything. So some clever people over 20 years ago came up across an epidemic or gossip protocol with which different key servers can reconcile their sets of data with minimum interaction. This is very important because, well, key servers nowadays have like 6 million keys. And if I upload an addition to my key in any of the key servers, it should be propagated to the other ones quite quickly in order for information to be reliable, for information to be available to anybody who comes across it. So this gossip protocol allowed for 20 years of large set reconciliation, but it's now at a very bad point. I will talk about a little why it's breaking, right? The main issue is that the key server network, well, basically works as a binary, non-modifiable, distributed, non-authenticated, eventually consistent storage. So anybody, without identifying themselves, can add arbitrary material to the key server network, and it will be replicated everywhere, and it cannot be removed once it's there. So when people started really understanding what's going on here, well, many different attacks appeared. I will not go over each of them. I will only, well, there's a easy path to understanding what went wrong here that brought part of the issue maybe 3 years ago, and then later other things happened. You see here this trolling the web of trust. We can create throwaway identities. We can create many keys which mean nothing. And somebody decided to decorate their keys by adding the signatures of, instead of personal names and email addresses, that's the usual use of this listing, well, they made some ASCII drawings. And, well, it's funny, it looks fine, it was shown in a hacker conference, but it gave ideas. And one of those ideas is, what happens if we start abusing the throwaway keys? Yep. This led to certificate poisoning, which was still mostly is a bad issue. Certificate poisoning is what happens when we abuse this network. Usually, people have something. People's like certifications follows one of these patterns. Either somebody is very even completely disconnected, or very slightly connected, or more connected, or strongly connected. Maybe some people can have up to some hundreds of connections to the network. But what happens if somebody, if an evil actor, an attacker, creates hundreds of thousands of throwaway identities and want to do evil stuff to one person? So now one person, this Vicky, the victim, is certified with hundreds of thousands of keys. Maybe Vicky doesn't even know about it. But when Alice wants to talk to Vicky and she goes to the key server will send her a very, very large key, which doesn't make sense, which is certified by garbage. And, well, implementations have taken care of this issue. Nowadays, very, very large packets will be, will discard part of this throwaway information, and newer implementations will defend in different ways from this. Will not fall to this. But anyway, this key will not be usable anymore, because it carries so much garbage that besides the download size, well, it brings a lot of it gets difficult to be used. So effectively, it's like overloading a truck. Yeah, and well, it posed a very significant threat. So why can't we delete those extra certificates? Well, because they're written in stone. Once something hits the key server network as it was conceived 20 years ago, it cannot be deleted from it, because it's an append-only medium. If I operate a key server and I delete some certifications, they will arrive back. If I specify to my key server, just ignore those certifications, well, every connection I make to other key servers, they will send it again, so I will be just spending bandwidth getting information I already had and discarded, because the algorithm requires things to be synchronized. And then mostly good development comes along, the GDPR comes along. So it's not only that I want to delete malicious information, but also if somebody legitimately had a social connection some years ago and now wants it to be forgotten, they can demand key server operators to remove it. And well, it is the law imposes conditions that are not compatible with the way key servers operate. So this last point, the GDPR compliance, is a very hard blow to the key server network. You can see that, well, I started gathering information even without knowing what I would do with it. But I started gathering information on the number of connections between key servers well over 3 years ago. And you can see there are certain breaking points here. This first breaking point was somewhat after the introduction of certificate poisoning. When, well, this is the number of responses, it's not the number of key servers, but never mind, this dropped sharply because key server operators realized there was nothing they could do, so many people just stopped running a key server. Here we see another breaking point. I think this also is related to a GDPR takedown request for some keys. This last drop was a measuring error, but right now we were here somewhere around the 400 connections. We are currently around the 30 connections I can make every day when I run this. So the key server network has shrunk a lot, and the reliability of the key server network has also been eroded. So we cannot be sure anymore that the different key servers are in sync. In fact, for example, many people recommend using the Ubuntu key server. I don't know why it started being recommended. The problem is that the Ubuntu key server is not connected to a large set of key servers. Good. Okay, so the central idea I am pushing is that, well, there are many other solutions. What I'm presenting here is, well, the thought process of maybe 2 years ago, and I didn't know many things that I know now. I didn't know of any other projects, but what I want to present is a solution to keep the distributed model viable without requiring centralizing entities. So I am taking the idea of the first-party attested third-party certification protocol. I will now explain this, but many of you have already used it. The thing is, have you ever heard of CAF? CAF is what we use for over 20 years in Debian circles and similar free software circles as a protocol to sign our keys and some implementation. But if these good practices were taken to be a requirement by the servers, this would help a lot. So if we were to certify keys and the key server would reject any key that's would require every modification to a key to be attested, to be accepted by the owner of said key. So if here Alice and Bob cross-validate their keys off-band, then Bob fetches Alice's key from the key server and generates a certificate on it. Instead of just sending it back to the server and the server accepting it, we would now require Bob to send it to Alice so she attests this certification and she sends it to the key server. So there is no way of, there would be no way following this for Alice to get certifications she doesn't want. I cannot create a fake identity of somebody else and sign somebody's key. Second, allowing UID verification. If the key server were to generate a token every time I send a key to the key server, a new key, instead of just accepting it, if it generates a token and requires this token to be sent back by email, of course, that would require all keys to have an email, which they don't currently. Then the key owner attests having received this token and sent it back to the server. Not only it would verify the UID, but it would also identify which server this key was sent to. And this is important for the next step I'm going to describe as well. So key server operators would be able to identify key servers that don't follow these rules, that are operating wrongly and accepting invalid UIDs. This would be important to keep trust in the data that's presented to users. And well, this is, I don't even have a diagram for this yet, but how could we use this for information removal? Well, the information would still be there, but not presented to the end users. Each key server would present their view on the data they all have. Their view would be they would only convey the information that that's attested to be coming from key servers they trust. Each person could also send a newer attestation where they remove, where they don't attest some key signatures or key modifications they have made. The old information is still there, but it's not served. And there are some implementation details I want to take care of, but one of the strengths, I think, of this idea is that OpenPGP data is like packets appended to a key. So I can send some packets and ignore some others. So, of course, this I am still pushing ideas and still not implementing anything. What I'm expecting to get out of this is to allow the decentralized public key server network to keep operating, mitigating the issues we have identified with it, and to be more in line with modern privacy expectations. I feel very important to keep the centralized transitive trust model relevant. So any ideas that bring centralization, I'm not really happy with them. I know that many ideas propose some kinds of centralization. Now, would this satisfy GDPR? I think not, because the information that is being requested to be removed would still be there, but it would not be served. And it's still, I mean, if this still builds on the gossip or epidemic protocols, the information would still be there forever. But users will stop receiving the information that's known to be bad. And I think that's good. Now, there's important points I was pointed at, that this could lead to death by kindness. What is this? Well, OpenPGP is known to be hard to use. It's known to be non-user friendly. It's known to be to put a lot of hurdles for its adoption. And well, it shows it. After 30 years, there are 6 million keys, yes, but there are many. There are maybe like tens of thousands of users. It's not more than that. It's not trivial. It's an amount that I think it's very important, but it hasn't grown beyond that. Mainly because it's hard to understand and hard to use scheme for many people. If we put extra hurdles, well, it may get more people to say, I don't want that. So, but I think still that these kind of modifications would be beneficial, or at least should be more researched into and followed. So that's the direction the project I'm doing is taking. Of course, yesterday I found this cartoon on the SMBC, the Saturday morning breakfast cereal comics. Yeah, it's very easy for people to propose like weird engineering tricks for solving something that has been solved in a different, easier way. But well, yeah, that's part of the nature of PhD studies, and that's what I'm doing. So I am required to do weird engineering tricks to attempt things that have been solved otherwise, right? So that's the material I have. I am, of course, most interested in hearing any comments you have, maybe even answering some of them. So please.
It's working.
One of the options I wonder if you've considered is you've talked about attesting the certifications what about if we just attested the entire upload to the key server of a key? So as a key owner, I would say, this is the key as I want it to be on the key server network, sign that entire thing, and that gives me two things. One is it gives me the curation over what certifications I allow to be on the key, but also should I wish to have stuff removed, I can upload purely a primary key, possibly a revocation certificate, no UIDs, no identifiable information. There's probably some nuances to be worked out, but I think it solves some of the problems you've been thinking about, and I wondered if you've considered that path at all, or...
That's where I want to get to. I cannot say everything's considered with this, but even if you already uploaded a key before that has your personal identifying information, but now you want to remove it, well, your key will still be complete in the key server history, but when you upload a new version of your attestation would be precisely how you want your key to be seen. What I imagine is that you would be able to look at all the packets that conform your existing key and say, I want this, and this, and this, and not the others. And push that, and the key servers that trust that particular view, and that's also a problem by itself, but the key servers that don't trust that particular view would only convey what you indicated to be the right way to show your key. Thanks.
Yeah, similarly to that, what I don't understand is why is there a problem with GDPR? If I decide which key is the valid one, then the key server network can gossip that one. If someone misbehaves, obviously they can keep older versions, but that's unavoidable. But any well-behaved key server would delete any older version of the key and just keep the latest that I signed and thus remove anything. And I mean, clearly, if it's on the internet, it could reappear at some point. But if your key server behaves, then you shouldn't have a problem with GDPR because you don't have the data. You don't have to keep it.
Exactly. Well, you do have to keep it. You do have to keep it because the reconciliation protocol requires all key servers to have the same. And whenever a packet disappears from one of the key servers, it's replaced by the same packet that comes from another key server. It's very, well, that's a part of the algorithm I'm not meddling with. I could.
But exactly, so we could change that so that we can also remove that and keep the most up to date.
The thing is, I know this will be a hard task to face, and I want to be as compatible as possible with the current implementations. I know.
Okay, I just want to take a question from IRC. Ephraim asks, if not keyserver.ubuntu.com, then what server do you suggest?
Let me... At some point, I mentioned this page. So, so right now, you can pick any, well, sks-status.gwolf.org. For example, for building the maps I sent you, I used keyserver2.computer42.org. The issue with this one is that this is still running SKS, which is mostly not recommended. But SKS does give us the signature information, which is being hidden by some others. Let me find just the successful one. Yeah. So here you have many. You can see keyserver.ubuntu.com doesn't pair with the others. It's the only island I found. I have used a lot pgpkeys.eu. It's quite reliable. But most of them are running fine. I'm not recommending a single one of them.
Hello? Hello?
Yes.
Hello? Can you hear me? Is it on? Okay, so we actually implemented 1PA3PC for keys.openpgp.org. That's not working? So, is it on? We implemented 1PA3PC in keys.openpgp.org, and I don't think it has ever been used, and I see two reasons for that. First, I mean, it's not a well-known feature yet, and also it's only implemented by Sequoia, as far as I know, and it requires active support from the holder of the certificate being signed, right? And if you are not using Sequoia, you have no chance of participating in the scheme. Mm-hmm. And the thing we want to fix, or we want to address with 1PA3PC, is the certificate flooding. And the problem with certificate flooding, or what enables certificate flooding in our mind, is that the cost of serving the certificate, the certification is associated with the certificate being signed. So the cost, so to say, is associated with the signed certificate. And we can turn that on its head by associating the certification with the signer, with the certifier. So an attacker, Mallory, can only flood her own key. And we kind of have a scheme for that. And the neat thing is that it doesn't require support from the certificate being signed, but it does require support from the party who wants to make use of the certification. And I think this will better fit the existing ecosystem and use case, and it will attribute the cost of both the certification and the adoption of the protocol with the right parties. And I'm happy to talk about that afterwards. Thank you.
Thanks. Yeah, there's only one thing I'm not convinced with the scheme you propose. I think it's very elegant, and I think it solves most of the issue. But what Jonathan said earlier, if I want to be able to control into the future the view of my key, the signatures should probably still be on, I mean, I should still hold the signatures I have received in order to be able to select which one of them to present and not make it too, say, computationally intensive. I don't know. I have really not thought much about this scheme you said. I mean, I am aware of it, but well, I mean, that's my justification for coming up with a different one.
I'd just like to say on the point of the synchronization protocol, it grew out of a PhD. I think there's an entirely new PhD in getting it to be resilient around the attacks we've seen, and I wouldn't get hung up on the synchronization problem when considering the certification problem, so I would decouple them rather than going, hey, it must work within the entire system, because I do think there's a lot of work needs done on the SKS side as well.
Yeah, I haven't followed SKS because, well, it's in a, I'm sorry to say, it's in a very sorry state of maintenance. But yeah, thanks.
Wouldn't using the web key directory protocol WKD solve a lot of these problems without having to add another layer of signatures on signatures by putting the user in charge of their own key?
Mm-hmm. Yes and no. WKD has a couple of shortcomings. First of all, I understand the protocol requires the key to be minimized and doesn't include the certifications on it. Okay.
It's just a web page. You can put whatever you want in there. I don't know why they recommend dropping the signatures from there. It doesn't make any sense, I guess.
Mm-hmm. Yeah, I see it in a similar way. But also, it requires keys to be in a domain you somehow control. If you have I don't know, Christoph@gmail.com address, good luck in getting your WKD to work. I mean, you can use it on Debian.org, but you cannot use it on a large scale provider.
Okay, another question from IRC. If Alice needs to attest to Bob's attestation, what if Bob wants to revoke his attestation?
Okay, so Bob signs Alice, Alice attests this, and later Bob wants to unsign Alice. I don't know, I mean, as you saw, I don't have anything coded. I am just sketching out what would be an interaction protocol. That's a case I think should be interesting to look into. Also, I would be interested in understanding what, say, not only the people using it, but also the laws governing this, like the GDPR would require in this case. But yeah, I mean, those are problems that should be somehow looked into.
Hello. What do you think about the Pretty Easy Privacy project, PEP? Is it a good idea? Pretty Easy Privacy, PEP?
Sorry again?
Pretty Easy Privacy, PEP?
Oh,
what is your opinion? Like, is it going to make things easier for GPG adoption?
I really don't know. Yeah, I'm not familiar with it.
Okay.
Sorry. So it seems we're set.
Thank you very much, G. Wolf. That was very interesting.
I was asked, please, to remind you, everybody, to sign up for a day trip option before 12 today, because otherwise you're not getting a day trip. Okay?
Please volunteer for the video team.
Thank you very much.